Applications of numerical methods in designing and analysis of a control system for a aircraft. The objective of the paper of the study is impulsion of the both aerometric of the proportion models of the linear interpoles using a lookup the tables in the database and the arithmetic and the depends upon the state control variable have the discoverable table of the model. Thus, some is simplified where we made development of the linear and aircraft stimulation. This with a bare graph and with a scale direction connection for the plots into a control surface defined. Aircraft. An aircraft is a vehicle or a mission that is able to fly by for the gaining of the support from the air support from a surface for the gravity using statistics on the left by using the dynamic lift of the air flowing. In the few cases the word thrust and the jet engines. And numerical methods are provide a way to solving problems quickly and easily and comparatively to the analytic solution. Whether the goal is integration or the solution of the complex differential equation, there is many tools available to the reduce the solution of what can be sometimes quick difficult analysis method to a simple algebraic. And the predicate of the zero dynamic performance. The aircraft design process is a realizing of the continuously growing a knowledge about the final product. Therefore, the detail and the aerodynamic and analysis is used to judge on a program with respect to and the aerodynamic of the overall aircraft performance. And CDF plays the increase the role of the business, and because it can be aerodynamic and the quantities with the accountable and at least the speed dynamic. This is finally allows the optimizer of the aircraft with respect to a certain customer or a market requirements like a typical mission. The average flight of the efficiency is measured as a fuel needed for a certain trip and divided by a distance. The ratio can be depressed through some main graph apparatus. This optimizing the fuel consumption and aerodynamically means to a design of the aircraft for the highest C by D and at the give a contain match number. The compared to a first A30 of today aircraft about the 46% of efficiency. Mathematical relationship in this aircraft. One of the important thing to remember before leaving the mathematical relationship by the step by step the formula proceed to a article. It is a meaning. It is a simple mathematical reduction of a panel method which the airfoil structure without examination with a very deeply. The first assume the consume and the consume and evaluately of the line ensures infinitely small. This is the next and other create the assurance of the line. The short space can be seen to a upper left corner. Is to edge image of the page. Again, we need to specific it as a parametric. The small part of the weld strength is TS reduce the infinitely a small potential at the point P, and equation 1 is given to in this way. d by d is equal to lambda ds by 2 pi by 1 n r. And in this equation the integral of the hitting the form that is the according to the RPJ panel the including speed potential and p will be in the speed delta phi phi j is equal to lambda j by 2 pi integral of 1n r pj and ds, and it is equation in the value of the panel, so the integral, so that the speed potential of the panel phi by xi by yi is equal to sigma n I is equal to lambda j by 2 pi integral of 1l r rij dsj. Now point P, where will be initial to determine, was arbitrary point. Let us put the point of the control, put point of the panel, this equation. We can see that the both formulas of it after the equation, by taking a certain steps of integration can be taken by adding a boundary condition in the forms of the equation like that. Thank you.